Hello, friends. Jim here. Welcome to Science Talk. Want to go over this report that came out recently at the end of October 2023. And title is the 2023 State of the Climate Report, Entering Uncharted Territory. The lead author is William J. Ripple, and there is a lot of co-authors on here. I will leave the URL in the comments section for those who wish to go over this, read it for yourself. I'm probably going to concentrate more on the diagrams and figures that appear, and maybe discuss some of the text. But you know, as I said, I will leave the URL so you can pull it up and look at it yourself. So they open up with life on planet Earth is under siege. We are now in uncharted territory. For several decades, scientists have consistently warned of a future marked by extreme climatic conditions because of escalating global temperatures caused by ongoing human activities that release harmful greenhouse gases into the atmosphere. Unfortunately, time is up. We are seeing the manifestation of those predictions as an alarming and unprecedented succession of climate records are broken, causing profoundly distressing scenes of suffering to unfold. Right? We're seeing this. We're seeing the floods, the precipitation bombs, the result of droughts. We're already seeing this. Wildfires, you know, displacing people. We are entering an unfamiliar domain regarding our climate crisis, a situation no one has ever witnessed firsthand in the history of humanity. Okay. Climate-related all-time records. In 2023, we witnessed an extraordinary series of climate-related records being broken around the world. The rapid pace of change has surprised scientists and caused concern about the dangers of extreme weather, risky climate feedback loops, and the approach of damaging tipping points sooner than expected. Well, for those scientists who have been warning of the exponentiation, we're not really all that surprised. We may have been surprised at the rate of exponentiation, but certainly not linear, as a lot of folks at the IPCC keep insisting on. This year, exceptional heat waves have swept across the world, leading to record high temperatures. The oceans have been historically warm, with global and North Atlantic sea surface temperatures both breaking records, and unprecedented low levels of sea ice surrounding Antarctica. And they reference figures 1A through 1D. We'll go over those in a moment. And oceans being warm. Well, that's because in the last 50 years or so, they've absorbed about 450 zettajoules of energy. So the stratification of the ocean is increasing, which hinders, prevents, whatever verb you want to use, sequestration of heat, and for that matter, CO2, to death. So that heat is staying in the upper layers, and some of it gets transported horizontally, like to the polar regions, where the sea ice is melting away, and the cantilevered ice as well, from the land. And a lot of that heat is also diffusing to the atmosphere, contributing to the warmer air temperature. And this record warmth in the North Atlantic is that heat staying in the surface because AMOC is slowing down. So we can explain a lot of that because the ocean heat content is basically, we took like a debt out on the energy use, and now that debt's being called in. That heat energy in the ocean is now diffusing to the atmosphere. Warmer atmosphere can hold more moisture, so the atmosphere can pull out more moisture from the ground, drying out the ground, making it prone to drought and fires, but also from bodies of water, fresh or marine. And then you have extra moisture, which then translates as extra precipitation. So if, if they act so surprised, but that's because they only look at the atmosphere. They're not listening to us oceanographers. So here's figure one. Let me see if I can get an enlarged view of this, sort of. And let's see, maybe I can increase this a little bit. Oh, but okay, I think that's visible. Okay, so hopefully it's visible for you guys here. So in A, we're looking at the Antarctic sea ice extent, which is in 10 to the 6 square kilometers. And this is compared to the 1991 to 2023 mean. Okay, now here's the scale. So this goes from January, April, July, October, presumably December 31st. Here. So here's July. July is the middle of the southern hemisphere's winter. Winter. This is supposed to be the cold time of year. Where's the ice? It's disappearing. And it's disappeared. This is relative. So the 0 is your baseline, right? This baseline average here. So we're what's that, 2 million square kilometers, almost pushing 3 million square kilometers in the middle of wintertime, almost 3 million square kilometers of less sea ice during the southern hemisphere winter. That is insane. Now, in all these first 4 panels here, they're all looking at the 1991 to 2023 mean. So now we're looking at the entire global sea ice extent, and we again see, okay, the red is 2023, just to be clear, right? We are basically seeing, globally speaking, so that's Antarctica, that's the Arctic Ocean. Sea ice is disappearing. Now here's the real nutcase here. Look at the North Atlantic Ocean sea surface temperature. This is the anomaly in degrees C relative to 91 to 2023. Look at this. I think Elliot Jacobson calculated this as being like 5 standard deviations. That's unprecedented, unheard of. And there's all that. That's all that ocean heat content. That's what this is. It's finally cooking in. And then when you look at the entire world ocean, Pacific, Indian, Southern Ocean, look at this. 2023 is just an incredible, anomalous year. Now let's look at the world's surface temperature. Now they're relating this to the 1850 to 1900 mean. And this is the surface temperature. This is at a 2-meter height. This is for land and ocean, all taken together. And we can see that once around July arrived, it started being above where the other anomalies were. So this is how much warmer compared to the 1850 to 1900 mean is, right? So this baseline here, and we're talking basically 1.5 degrees warmer, when compared to this 51-year period, include the endpoints. Right? So we're seeing the ice disappearing globally. We're seeing sea surface temperatures increasing dramatically. This is we're talking half a degree C anomaly compared to 1991 to 2023 mean, and this is looking from 60 degrees south to 60 degrees north. Right? Keep in mind the specific heat content of the oceans. That is a very troubling trend that reflects, as I said over here, it reflects the massive ocean heat content. And a lot of that diffuses to the atmosphere, and we're seeing the warming planet. More, sunlight energy comes in the UV, and then it's reflected out in the IR, ultraviolet, infrared out. A lot more of that infrared is being trapped. We're actually seeing stratospheric cooling, but tropospheric warming, and that enables the heat to be trapped. And then this is scary right here, folks. This is cumulative area burned in Canada in terms of million hectares, right? So for basically, towards the end of September, we're looking at about 16 and a half million hectares of land burned in Canada. Look at the rest of the years. Oh, it'd be about in this middle September, the summer, towards the end of September, kind of flattens out. This just keeps burning. It keeps increasing. This is very scary. And we've seen fires, in Alaska in recent years, in Scandinavia, Siberia. Basically, the boreal biome is burning up. And the boreal biome is actually the largest terrestrial biome in terms of, area. So this is very scary, and chances are there will be zombie fires throughout the winter, and this stuff will reignite come next spring. So they go, so they talk about, variables falling outside of historic range, including, as I just mentioned, what's going on in Canada, may indicate a tipping point into a new fire regime. They talk about Antarctic sea ice reached its lowest daily relative extent since the advent of satellite data. In the middle of their winter. Anthropogenic global heating is a key driver of many of these recent extremes. Then they go on to say rising Atlantic Ocean temperatures may be connected to Sahel rainfall and African dust. Another potential contributor is water vapor, which is a greenhouse gas. I mean, when you burn hydrocarbons, right, you put gasoline in your vehicle and you burn it, not just CO2 that comes out the tailpipe, CO2 and water. And studies have shown that CO2 and water vapor working together makes for a more potent combination at trapping heat. Now, you can get, if a volcano basically sends up water vapor into the atmosphere, you can get a warming. If it sends up, particulates, then you can get a cooling, basically like aerosols. Okay? Recent rise may also be linked to a regulatory change mandating the use of low sulfur fuels in ocean shipping because atmospheric sulfate aerosols directly scatter sunlight, cause reflective clouds to form. Recent sudden rise in temperatures may also be the result of the El Nino that's setting in. And it looks like it's going to be a strong El Nino. So as Earth's climate system transitions away from conditions associated with human thriving, such anomalies may become more frequent, have increasingly catastrophic impacts. So in figure 2, they look at 35 vital signs are now showing record extremes. So again, let me open this up in a new tab, increase what we've got going on here. Human population. There it is, over 8 billion. The problem is, underlying cause, could, in addition to burning all the fossil fuels, is too many people. More people have more demands. Demands for food, demands for space, demands for energy. All this requires harvesting, utilizing resources to meet the ever increasing demands. But resources are not finite. At some point, they're going to be depleted. Because I did a video on this about 2 years ago about human population being too high for the planet. The carrying capacity, based on, I did a survey of some 40 plus papers. The low end was 20 million, the upper end was 1 billion people. The median was 100 to 600 million people. In other words, the carrying capacity is between 100 and 600 million humans that this planet can sustain so that people can utilize resources, allowing the resources to be renewed. Right now, we're depleting the resources faster than they can be renewed. At some point, it's going to crash. This one here is showing a declining fertility rate for women from a little over 3.5 down to about 2 children. And by the way, the scale starts from 1980 to 20 to the current. So we're talking about what, basically a 40-year period. Number of livestock are increasing. Wildlife biomass is massively decreasing, being supplanted by domestic animal biomass. Your pets, your cat, dogs, right? Hamsters, and so on, but also the livestock that humans keep. Livestock are increasing, and they fart. They fart a lot, adding methane, and it is an important, significant contributor to warming. And then I go through GDP, global tree cover loss. It kind of peaked out at about the late 2010s, but we can see the trend is increasing. A bit of a downturn in recent years. There's less tree cover has been lost, probably because we're running out of trees to cut down in the first place. The Brazilian Amazon forest, the lungs of the planet, has been often called. Right, had a couple of peaks in the mid 1990s, again in the mid 00s, and then started dropping off because it was massive logging. And now the losses started to increase. So there was some changes in government policy to reduce the cutting, and now the felling of trees is reducing. Energy consumption, oil, coal, gas, and then solar, wind. For the longest time, this was pretty much flat. It started to pick up, but it still is lagged well behind oil, coal, and gas, which we can see a clear increasing trend. Coal seems to be stabilizing, coming down a tad, not it's not quite clear to me which of these dots go to which. But the energy demand and consumption are increasing. Air transport. Notice it keeps going up and up and up. This is in terms of passengers carried per year. There's this massive drop off. That was COVID, and now it's coming back up. CO2 equivalent emissions measured in gigatons. There was a slight decline because of COVID, but it's coming right back up. And we see the similar results here for per capita CO2 equivalent emissions. Again, this decline is COVID, and it's coming right back up. And fossil fuel subsidies in terms of billion US dollars per year. Why are governments subsidizing the fossil fuel companies? Look at this massive jump. So some of these indicators are showing troubling trends, basically. And of course, when you're viewing this, you can always pause the video and scrutinize it at your with a comfortable time leisure for yourself. So figure 3 shows some climate-related responses. So let's open this up. And again, I'm going to see. There we go. Let's get that out of the way. Well, this should not surprise any of you. CO2, methane, nitrous oxide, all increasing. Time frame is again from basically 1980 to the present. Okay. And we can now CO2 is over 400 parts. Look at the scaling. It almost looks like it's reaching close to 425, according to this here. Methane increasing well over 1900. This is measuring parts per billion for methane. CO2 is in per million. Nitrous oxide is also in per billion. But it doesn't matter because it's just shooting up. See, surface temperature anomaly. So this is overall surface temperature measured at the 2-meter height. Okay. We clearly see an increasing trend. Again, the up and down reflects seasonalities. Fit the line through it. Obviously increasing. Earth's energy imbalance. This is measured in watts per square meter based on a 12-month running mean. This imbalance is basically at 1.5 watts per square meter. That is extremely significant. That is extremely troubling. Some say that the reduction in aerosols contributing to that. There's no doubt that does contribute. I contend it's also the ocean heat diffusing to the atmosphere, adding to the imbalance. And speaking of which, ocean heat content change. This is in 10 to the 22nd joules. Okay. Now they started getting some really good data. Well, this data here goes back to the mid 2000s, and we just see an increase. This is troubling. All that heat energy is going into the ocean, and now the oceans are returning that heat energy. Ocean acidity, the pH, dropping. It's gone from basically, say, 8.12 to about 8.07. Remember, now this may not sound like much. It's only from 0.12 to 0.07. This is a log scale. The pH is a log scale. This is a hell of a lot. This is a very troubling decrease in pH that's already affecting organisms. Organisms are losing the ability to precipitate shells, for those that make a shell, which leads to increasing mortality. The calcite compensation depth is getting shallower. Basically, below the calcite compensation depth, the CCD, calcite tends to stay in solution. Above it, it tends to precipitate. Well, if it's getting shallower and shallower, it's going to be more and more difficult for the organisms to make their shells. Sea level change, okay, relative to a 20-year mean. This is measured in millimeters. Well, we see what? 50 millimeter increase. That's 5 centimeters. That's 2 inches. May not sound like much. Consider the surface area of the planet. That's a lot. Minimum Arctic sea ice. Overall trend, decreasing. Greenland ice mass in gigatons. A drop of nearly 5,000 gigatons. Antarctic ice mass change, again in gigatons. About 2,500 gigatons. Glacier thickness change, meters of water equivalent. Bam. Nearly 30. Decrease, right? These are decreases. And then we have area burned in the U.S. Right? We did the one in Canada. Well, we see a lot more fires going on in the U.S. Global tree cover loss due to fires. So not only fires, but logging, right? Also causing the loss of tree cover to increase. Little downturn, but when compared to earlier years, it's a significant amount. Extremely hot days relative to 1961 to 1990 percent of days per year. So in other words, that's the baseline, right? What do we see for the last 40 years? There are more and more days where it's extremely hot. It's a hotter planet out there. Well, don't forget the wet bulb temperature is about, what, 31 C? Above that temperature, the human body has a difficult time keeping itself cool, putting people at risk of hyperthermia, and it affects the elderly more so because they have more difficulty thermoregulating their body temperature, and the result is increased mortality among the elderly. But even, people who work out in the sun, your construction workers, your farmers, your crop pickers, they're out there in the blazing sun. They're at risk. And all these things I've shown you, you have heard me discuss these with you in basically standalone videos, over the last how many years I've been doing this. I've shared with you all of these things here, especially with the ocean stuff. Okay. This is an interesting statement. It appears the green recovery following COVID-19 that many had hoped for has largely failed to materialize. This is based on Zhang et al. 2023. Now, Zhang is the gentleman who has been putting out the ocean heat content summaries every year. Instead, carbon emissions have continued increasing. Fossil fuels remain dominant. Annual coal consumption reaching a near all-time high of 161.5 exajoules in 2022. Although the consumption of renewable energy, solar and wind, grew a robust 17% between 21 and 22, it remains approximately 15 times lower than fossil fuel energy consumption. And I showed that to you earlier. You saw the lag in that. A major driver of economic and energy trends is Russia's ongoing invasion of Ukraine, which has accelerated the transition to renewables in Europe, but may have also caused some countries to switch from Russian supplied gas to coal, and all the problems associated with that. Forests. The global tree cover loss declined 9.7% to 22 million hectares per year. Similarly, the Brazilian Amazon forest loss rate decreased by 11.3% to 1.16 million hectares per year. Further reductions are likely to occur as a result of the election of Brazil and several recent legal decrees. However, humanity is not on track to end and reverse deforestation by 2030. Moreover, forests are increasingly threatened by powerful climate feedback loops involving processes such as insect damage, dieback, and wildfires. And don't forget the logging, right, which they alluded to above. Okay. Global mean greenhouse gases and temperature. Well, we know what's happening there, right? Continually burning the fossil fuel, continuing to add greenhouse gases. We have the thawing permafrost adding methane and nitrous oxide. We've got the methane found in the ocean shelves. They're now basically being released. All this is adding increase in the CO2 equivalent levels. Right? It's all happening. Here's an interesting statement. Although fossil fuel-related greenhouse gas emissions are a main driver of rising temperatures, true, a global decline in sulfur dioxide emissions is likely a contributing factor. Sulfur dioxide forms sulfates, which is basically a cooling effect. So it can dampen the warming signal. And don't forget, you have the ocean heat content fluxing, diffusing to the atmosphere. Well, how did that heat content appear in the ocean in the first place? Burning fossil fuel. Oceans and ice. Ocean acidity, glacier thickness, Greenland ice mass all fell to record lows. Sea level rise, ocean heat content rose to record highs. We just looked over that in the figures earlier. Increase in heat content, rapid rise in sea surface temps, especially troubling because they can have many serious impacts, including the loss of sea life, coral reefs dying because of bleaching, rise in the intensity of large tropical storms. There are also growing concerns of AMOC could pass the tipping point and start to collapse. And that could significantly alter global precipitation and temperature patterns. And don't forget, as the oceans stratify, productivity is at risk. And if productivity falls off, then you're going to have species diversity falling off in the oceans. And let's not even talk about overfishing, all contributing. So, oceans are in trouble. And don't forget, the phytoplanktons die off. Well, they supply 55 to 80% of atmospheric oxygen. You don't need to be a genius to know what that means. It will impact us. And by the way, there is starting to be some measurement of a declining oxygen content, oxygen levels in the atmosphere. Climate change is contributing significantly to human suffering, right? I don't need to enlarge this here. You can see all flooding, fires, drought, storm, bombs. This is a poor woman in her home, right? All from extreme weather because all this heat energy is trying to be redistributed. And if you want to look at it from like a chaos theory aspect, right? We have perturbed the system in such a dramatic way and continue to do so. And the system continues to be perturbed because of the positive feedback loops that the system, in trying to find a new equilibrium state, cannot because of continual perturbations. So here's a table. I don't know if I'd be able to. Yeah, let me open this up in a new tab. Oh, that didn't really do much. Can I increase that? All right, well, I'll try. Okay, November, December 2022. Record-breaking heat waves in Argentina and Paraguay contributed to power outages, wildfires, poor harvest. Extreme heat was estimated to have been made 60 times more likely because of climate change. December 22 to March 23. Heavy rainfall caused by atmospheric rivers led to multiple floods in western U.S. February 23, Cyclone Gabrielle caused extreme rainfall in New Zealand. March to May 23, record-breaking temperatures were recorded in parts of Southeast Asia, China, South Asia. The extreme heat caused deaths and school closures in India. January to July 2023, intense wildfires in Canada. Right, we already went through that. May 23, tropical cyclone Mocha reported to kill at least 145 people in Myanmar. May to June 23, tropical storm Marwar caused flooding and loss of power in parts of Guam. Marwar was the strongest cyclone ever recorded in the Northern Hemisphere. Climate change may be causing an increase in the intensity of tropical cyclones. That's because, primarily, what do cyclones do? They suck heat energy from the oceans. Well, if the oceans are a hell of a lot warmer, there's a hell of a lot more energy to suck up. And remember, cyclones, hurricanes, typhoons, they are all energy distributors. They are mechanisms to distribute energy. And you're putting a lot more energy into these storms. There's going to be a lot more damage, a lot more impacts and effects from them. June 23, deadly heat led to more than a dozen deaths in the southern and midwestern U.S. July 23, up to 6 people died in southwest Japan because of heavy rainfall, causing floods and landslides. July 23, heavy monsoon rain caused flash floods and landslide in northern India that killed more than 100 people. June to August 23, extreme heat in the U.S. killed at least 147 people. July to August 23, Beijing, China experienced its heaviest rainfall in at least 140 years, major flooding affecting 1.3 million people. August 23, in Hawaii, U.S., catastrophic wildfires on the island of Maui killed at least 111 people, more than 1,000 still missing, right? And then September 23, Storm Daniel caused extreme flooding in Libya and parts of southeastern Europe. And we just had that storm with Siren that hit, France, southern UK. So we're seeing climate change in action. It's here, it's now, it's taking place now, it's happening. So, scientists have their, their suggestions. I'm not an economics person here, so I'm going to skip this section here. But again, I'll leave the URL for those who want to look at this. Okay, stopping warming. They still can hope that we mitigate, we can get the warming to slow and stop. No, I don't think so. The ocean heat content alone is enough to have this locked in. Now, how much does the planet, increase by the end of the century is open to discussion. But, it looks like that at least a 5C warming is pretty much locked in, and it could go all the way up to 10 or 11C. But that's all moot because an increase of 3 to 4C is sufficient to render humans extinct. And we're definitely going to hit that. Stopping coal consumption is, of course, an important thing to do. We have a lot of feedback loops. As the atmosphere warms, okay, for example, the extra heat will further thaw the permafrost, allowing more methane to be released, causing more warming, causing more thawing, causing more methane, etc., etc. Increasing ocean heat will cause the shelf system to release more methane. So we're seeing, and there's been so many other types of feedback loops that we have basically kickstarted. Reinforcing feedback loops amplify the effects of greenhouse gas emission, leading to additional warming. Now, I did a 2-part video some time ago, and it was led by the PIK group, and they did an analysis of the interactions among climate tipping elements. Which ones tend to be positive feedback loops, which ones tend to be negative feedback loops, and how does the interaction overall, now the summation, positive plus negative, what's the overall? And at the time I did this, I think it was about almost 2 years ago, they had concluded it was a 1.3 warming at that time. When people were talking about, oh, it's 1.0, 1.1 maybe, they're already talking 1.3. And it's probably warmer. Food security and undernourishment. This is a biggie. We're losing arable farmland. As population increases, there's going to be a demand for housing and then a land to produce food to feed the people. Well, there's only so much land. There's only so much usable land. So where are you going to house the people? And two, will the land provide enough food? Well, numerous studies are now quantifying that the nutritional content of the food that is harvested is lower. So the caloric content is not there, in addition to yields declining. So the increasing temperature is causing crop yields to decline, and at the same time, the nutritional content is also declining. So when people say, ooh, more CO2 is more plant food, well, they're wrong. I just did a video on the problems that plants are facing with the stomata. You might want to check that out. Okay, so what are the conclusions? Well, the effects of global warming are progressively more severe, and possibilities such as worldwide societal breakdown are feasible. By the end of this century, an estimated 3 to 6 billion individuals, about 1/3 to 1/2 of the global population, might find themselves confined beyond the livable region, encountering severe heat, limited food availability, elevated mortality rates due to climate change. The late James Lovelock postulated that by around 2075, give or take, that there'll be 2 billion people on the planet. Well, it's currently 8 billion. So he's basically saying 75% reduction. And that would be due to the effects of climate change. starvation, uh, not having access to potable water. And one thing that's not discussed here is as the planet warms, what disease organisms will be unleashed. So you're going to have pandemics running about, causing more severity. Pathogens that humans have never encountered before. It's going to wreak havoc. And we'll probably have wars over clean water. To address the overexploitation of our planet, we challenge the prevailing notion of endless growth and overconsumption by rich countries and individuals as unsustainable and unjust. We advocate for reducing resource overconsumption, reducing, reusing, recycling waste, and a more circular economy. So basically, instead of having an economy based on growth, have an economy based on sustainability and recycling. Now, I can't argue with that. Is it possible to implement? Who the hell knows? I'm not optimistic. I'll put it that way. So I just kind of hit upon certain aspects of this. I'll leave the URL in the comments section if you wish to read it in the greater detail. This, believe it or not, this is just a quick, perfunctory perusal of this. But you have heard me discuss many of these topics, issues before. So I wanted to share this with you, and I hope you found this informative, even if it is a bit sobering and depressing. But there it is. This is where things are at right now. Not really a very nice, pretty picture. Thank you for your time. Until next time.